Okay, we're going to answer a couple of questions with this image right here. Now, this image is of a carbon atom shown via the shell model. Now, notice in the shell model, you have protons and neutrons in the nucleus, okay? So the blue positive are protons because protons have a positive charge, and the red with nothing in them are neutrons because neutrons have no charge. Now remember, protons stay in the nucleus. They do not go anywhere else. Neutrons stay in the nucleus. They do not go anywhere else. But we still have one thing left, which is this tiny little negatively charged particle here, which we call an electron. Electrons are negatively charged, and they stay out here in what we call electron shells. And that is where the shell model comes from. The shell model says that electrons are around the nucleus in specific places called shells. That's where we're most likely to find an electron. Okay? Well, each of these shells can only hold a certain number of electrons. Now, carbon only has two shells, 1 and 2. The first shell of any atom can only hold 2 electrons. It's the smallest shell, and so we can see here that there are 2 electrons in the first shell. Now, the first shell is the one that is closest to the nucleus. Yeah, there we go. In the second shell, we've gotten a lot bigger. We can see there are at least 4 in the second shell. Well, if this were full, it would hold 8 electrons. The second shell can hold up to 8 electrons. And the third shell is the same way. It can hold up to 8 electrons. Okay? So now that we know how many electrons fill the shells, each of the first 3 shells, we need to discuss what it means to be a neutral element. Now, a neutral element means that there are no charge. So just like a neutron has no charge, that's also what neutral means. So that means we're looking for a charge of 0. Therefore, we want our protons to be the same as our electrons, because we don't want to have any charge. So if we have the same number of positive charges as we have negative charges, then we will have a neutral element. Finally, the last thing I want to talk to you about in this video is the shell model and whether or not it is the only correct atom model, and the answer is no. There are many atom models that each have pieces and parts of them that are more correct than others. There is no one atom model that is completely correct because we can't see atoms at this level yet. And one day, hopefully, we'll have a microscope capable of doing that, but until then, we have to use each of these models in different times and different places to help us understand what's happening. So let me know if you have any questions, and good luck on your retry of this question.